Hi everyone, welcome to VLSI Explore with Ram. Today, let's discuss PC enumeration. Enumeration means it is a process of discovering the topology and it will configure the PCIe devices. It will do two operations. One is it will discover the topology and it will configure the PCIe devices. See, this is processor. Processor only know the host bus. It is connected to bus 0. You don't know about how many components are connected below. What are those components? Let's consider our software is not configured any devices. What will happen? Let's see here. This is host bus. It need to drive traffic, config traffic to up to this device. Okay, let's see this host bus driving the packet. What is the path? This is the path. Yeah, this is our destination point where the packet need to be get. It need to cross this device. Yeah, this is the path now. It need to cross this device. But here this device having a two options. One is whether it will route the data to this component or whether it will consume the packet. That's why you have to be configure this device. It will understand whether it will route the packet to this component or it will consume the packet. And also let's consider you are not this packet which is this host bridge wanted to drive on memory traffic. Whenever if you wanted to drive any memory traffic at that time you have to be enable memory space enable bit in devices. Then this component will respond for the memory request. Otherwise it will send the unsupported request. You have to be configure the devices before sending actual packets. It will understand the topology. What is this component? How many components are connected entire topology. So our software need to understand. Then it will drive the traffic here. Now, how our processor software will understand what are the component, what are the type of the component it's present inside the fabric by reading the configuration address space. This is configuration registers inside the our design, which is the PC device. Inside the device, these are the registers configuration address space. Configuration address space are 256 bytes. This is type 0 header. 64 bytes for the header space. This is the complete header. It is 64 bytes. There are two types of the header space. One is type 0, type 1. Type 0 will indicating the endpoints. Type 1 will indicate the bridges, switches, root ports. Here you can see these colored boxes, which is this colored one all are read-only registers. This is base address register. Whenever our components, which is our root port, wanted to send memory traffic, at that time you have to be configure the what is the limit, what is the base address for the memory traffic. How you can configure by using this configuration address space, this configuration address register. You have to be configure the size and what is the starting address. Then it will map the system memory. You have to be configure the this base address registers before driving the any memory traffic. Here you can see type 0 header having a 6 bars, bar 0 to bar 5. For the type 1, bar 0 to bar 1, only 2 registers are there. Now this is for the PCIe and also 64 bytes for the header space. Remaining bytes 192 bytes are the capability structure. It is for the power management and interrupt registers at the time. These are the cabinet success. You have to be use these registers. It 4 KB configuration space for the PCI Express function. Here you can see this is for the PCI. It having a 256 bytes. But for the PCI Express it is 4 KB configuration space. PCI Express having a advanced features compared to PCI. It having a PCI extended configuration register space. It have advanced error reporting. Advanced error reporting means device will issue the error message to any component, whether that request which is it received one malformed TLP. At the time, device will issue the error message to any component. If the advanced error reporting enable there inside the DUT means at the time it will issue the memory this message error message to the any root port or to upstream side of the device. It will send. This is the configuration space. Now, how the processor come to know what is the device, what is the type of the device by reading the header type register. Here you can see this is a header type register. By reading these registers, our software will understand what is the type of the device. Header type, this from 0 to 6 is header type. It will indicate 0 will indicating the endpoint, 1 will indicating the bridges, 2 indicating card bus bridge, bit 7 will indicate the whether it is a single function device or multi-function device. Now what will happen here, understand by reading that header type it will understand what is the type of the device, whether it is endpoint or a bridges or a card bus bridge. Now see, this is processor. Processor only know the host bridge. It's connected to bus 0. You don't know how many components are connected. Processor will issue the instruction to this host bridge for sending the config packets. When it will send the config packets, when all the devices are enter the L0 state. L0 state is the state where the actual packet transmission will occur. Link up is occurred, then dial up is achieved, which is all the flow control packets are exchange happen. Then this host bridge issue the config packets to this device 0. This device 0 it will issue. Here actually how it will send the config packets by using the BDF. BDF means bus device function. For this bus 0 it's possible to connect 250. This having a bus as 0 to 255 and also devices are 32. Functions are 8 functions for the each device. Yeah, you understand now how many buses are there? 256 buses can be possible, and how many devices? 32 devices are there, and also 8 functions are there for each device. Here you have to understand primary bus, secondary bus, subordinate bus. See here, primary bus will indicating the upstream side of the bus. What is the upstream side of the device here? It is bus 0. What is the downstream side of the device? It is bus 1. See here, I will make point. Yeah, here you can see primary bus will indicating the upstream side of the device. Secondary bus will indicating the downstream side of the device. It is bus 1. See, its secondary bus is 1. Subordinate bus means what is the highest number bus for this topology. See, for this topology, what is the highest bus number? It is 4. Yeah, that's why it is 4. First, after that all the devices are enter the L0 state, this host bridge will initiate the type 0 configure it. This is type 0 configuration read. This is the type. Type field will decide what is the request it is, whether that is a config transactions, memory transactions, what is the type of the transactions, it will decide. 00100 indicating the configuration read for the type 0. Type 1 for the configuration read means the type will 00101. By sending the config request, type 0 config request, our host will understand whether the component present or not. How it will understand component present or not? It will read the vendor ID. See, this is the vendor ID, offset 0 vendor ID. What is the bit size? It is 16 bits, 4Fs. Yeah, what is the maximum value? It is 4F, no? Yeah. Whenever this host bridge will initiate the transaction, which is the config transaction initiated to offset 0 for reading the vendor ID. Vendor ID will assigned by the vendor. It has unique value. Vendor ID is less than all the bits values once. Here you can see it is 16 bit 4Fs. It is less than the 4Fs. At that time, what will happen? This host bridge will understand device is present. It will understand. See this header type, which is will write header type is F. It is vendor ID. Okay, vendor ID is all are FF. It is 16-bit field. Whenever the vendor ID is all F, indicating the device is not present, because each vendor will assign different vendor ID, which it has some unique value less than this value. Okay, then device is present. Here device is present. Whenever all the values less than the F means device is present. Now what will do? It will understand our processor, which is it will understand device is present. Now it need to understand what are the component. What is this component? How it will understand? By reading the header type. By reading the header type, it will understand whether that is a endpoint or a bridge or a card bus bridge. By reading this header type, it will understand what are the component. Yeah, this is the header type. By reading this, it will understand. There are two possibilities here. See, here after the detect, which is the whenever the reset power on, what will happen? It will start with the detect state. Detect to it need to reach to L0 state. But between that, L0 state is reached by the DUT. Our all the PC devices are reached, but maybe device is not present. Device is present, but device is not ready to respond. There are some combinations here. Device is not present, device is not ready to respond. Let's consider device is not ready to respond. At the time, what it will do? It will this device 0 will issue the completion with respect to the configuration request status. That is inside the completion status. The bit field indicating the configuration request status. It will indicate to this host bridge. Then host bridge will understand device is present, but it is not ready to respond. After some time, host bridge again initiate the transaction. At that time, device is ready to respond. Now here we understand device is ready. Now what is the process? It will read the header tab. After that, what it will do? It will do the configures. Type 0 configures for this device 0. What it will configure? It will configure the primary bus, secondary bus, subordinate bus. It will configure the first. It will understand our host bridge understand device is present. It will write primary bus equal to 0. Primary bus equal to 0 and secondary bus equal to 1. Subordinate bus equal to FF. See, primary bus is 0. Yeah, primary bus means upstream side of the device. This upstream side now it is a primary bus. It is 0. Downstream side of the device it is bus 1. Yeah. Subordinate bus is FF. Why it's writing all FF this FF value for the subordinate bus here? Why? Because here you can see you don't know. It need to check all the tree. It need to check all this tree. Then it will configure the subordinate bus. You don't know now what is the highest number for this topology. You don't know. It only know the second bus is available. Yeah, it understand second bus is available. Okay. It will configure the bus 1. Yeah. Subordinate bus is secondary bus is 1. Primary bus is 0. Then subordinate bus is FF. Now, what is the operation it will do? Same thing, which is first it will read the vendor ID. Yeah, see, I will. Yeah. It will read the vendor ID here for bus 1. This is one, you can see one device is present. For the bus 1, one device is present. It will configure. It will not configure first. It will read the vendor ID. Okay. After reading the vendor ID, then it will read the header type. First, you have to understand the process. What is the process enumeration will do? First, it will read the vendor ID. Then, after that, it will read the header type. By reading the vendor ID, it will understand device is present or not. By reading the header type, it will indicating what are the type, whether that is a switch or endpoint. It will understand. Yeah. After that, it will configure the primary bus, secondary bus, subordinate bus. It will configure. See, it is this host bridge initiate the transaction, which is it will initiate the bus 1 transaction. Type 0 bus 1 transaction initiated. At the time, it is a primary bus equal to 1, subordinate bus equal to 2. And subordinate bus equal to FF. Secondary bus is 2 here. See, 2. Now it will read the transaction, which it will read the vendor ID. It will read the header tab. It will understand. Okay, this is the bridge. Then it will configure the primary bus equal to 1, secondary bus equal to 2, subordinate bus equal to FF. This completed. Okay. It is completed this device settings. Now again it will insert the transaction for bus 2. The device is it's configured with respect to primary bus equal to 1, secondary bus equal to 2, subordinate bus equal to FF. It's configured. Now host to bridge will insert the transaction, configure transaction to bus 2. This is device 0. This is device 1. For the bus 2 having a 2 devices, device 0, device 1. It will check the device 0. See, device 0 present. Okay. Then first it will read the vendor ID. Then it will check the header type. After that, it will configure the primary bus, secondary bus, subordinate bus. Here you can see it is first it will check primary bus. What is the primary? It is 2. So secondary bus is 3. Secondary bus means downstream side of the device. What is the downstream side? This is bus 3 now only available bus 3 downstream side. Now this bus 2 this configuration complete. This device is configured. Okay, with respect to primary bus equal to 2, secondary bus equal to 3, subordinate bus equal to FF. It's configured. Completed. Now what is the operation it will do next? It will read the bus 3. This host to bridge will insert the traffic, which is it will insert the config traffic to bus 3. It is initiated. Here this is the last point, which is this is end point. Okay. After reading the vendor header type, which is it will indicate header type 0 will indicate the end point. Then it will register. It will by reading header type it will come to know this is the end point. This is the last stage. No need to be configured. Okay. Then it will configure the subordinate bus. because it understand what is the highest topology for this block. Here you can see only bus 3 only available. This is highest bus number. That's why it will configure the bus 3. Okay, it's configured. Subordinate bus equal to 3, primary bus equal to 2, secondary bus equal to 3. After reaching the last stage, it will configure the subordinate bus. Okay, then device 0 is completed. Then it will move to device 1. It will send the config traffic to device 1. Device 1 is a primary bus. What is the primary bus? Upstream side of the device. It is bus 2 na? Yeah. Downstream side is 3. It is 4 na? Yeah. Here you can see 4. Downstream side of the device is 4 here. Now, what is the subordinate bus here? It will FF. Because you don't know how many components are connected below. Okay. It will write FF here. Subordinate bus. After that, device is present. It will understand it is a bridge. It having some devices. Okay. It will move to again bus 4. This host bridge will initiate the traffic here from this point, which is bus 0 to again insert to bus 1. Then again reach to bus 2. After reaching to bus 4 here, it will reach. It will understand this is the last stage. This is end point. It understand it is this is the last step. Then it will configure the subordinate bus because initially it's configured FF. You don't know what is the highest level. That's why it's configured to FF. But it understand this is the last stage. Only bus 4 only available. That's why it is configured the bus 4 here. Completed. Then again it will configure this subordinate bus for this one also because it is the highest level here bus 4 only. See, it will configure up to it will configure the bus 4. If any device are available, this device 0 is completed, device 1 is completed, any other things, device 1, device 2 also there, then it will check it will read the config space, then it will assign the bus number, primary bus, secondary bus and subordinate bus. This tree is completed. Yeah. Now all the traffic, similar thing. First, what the process it will do? First, it will read the header register, which is vendor ID. It will read first. Then after that, it will check what is the device, whether it is endpoint or a bridge. By reading the header tab, it will understand. Yeah, that is completed. Then what it will do? It will configure the device. What it will configure? What is primary bus, secondary bus, subordinate bus? It will configure. Only type 1 header having the primary bus, secondary bus, subordinate bus registers. For the endpoint, you don't have any primary bus, secondary bus, subordinate bus registers. Okay, header type this type 0, it is endpoint. Type 0 for the endpoint, type 1 for the bridges and root ports. This tree is completed. Okay, similar thing, it will achieve same way. Here you can see what is the maximum bus here. It is, see here, it is this is the 9 for this block. Bus 8. Again it is bus 9. This is it will start. This is device 0, device 1, device 2. First it will check device 0. Okay, bus 7 is there. Then it will move to this device 1. Okay, it will check the bus 8. Okay, what is the highest number? What is the bus number? It is 9. It will update to here. So what it will update here. Okay, after understanding it is the 7 bus equal to 9, it will update. Now what will happen? Then it will read this again device 2. It will read the device 2 registers. It will check all the buses and how many components are connected. Similar way, it will read the vendor ID and device ID. Yes, similar process it will do. This is the process it will start completed. Okay, enumeration is completed. It will understand topology. This every topology is completed. Checking the what is the device, what is the vendor ID, everything is configured and completed. Okay. Now what is the operation you need to do? See, there is something we have to understand here. This host bridge initiate the type 0 request to this bridges, but whenever this consider this type 1 for the what is the type 1 header? It is for the bridges. Type 0 for the endpoints. Now host bridge need to initiate the transaction, which is it need to insert the endpoint. to config transactions. But if you insert the transaction, what will happen? Type 1, which is type 1 will indicating the it is header space, which is it will for the bridges only. If you insert with respect to type 1, it will send unsupported request. This bridge which has this endpoint will send an unsupported request here. That's why initially host2 bridge will send the type 1. Okay, it will send the type 1 request. What will happen? This device will understand. Okay, this is not a request for me. This bus 0, which is a device 0, understand. Okay, this request is not for me. Then it will route to bus 1. Then bus 1 will understand because this is type 1 request. Okay, this is not for this bus 1 also. Then it will route to bus 4. See here, bus 4. Okay, this bus 4 need to again convert to type 1 to type 0 because endpoint will support the type 0 request only. But here what will happen? It's sending the type 1 request. With respect to the BDF, it's sending with the type 1 for the endpoint. But endpoint will not support the type 1. It will support the type 0. That's why whenever the packet, this type 1 config read packet reaching to this device, this device will automatically convert the traffic, which is type 1 to type 0. It will convert here. Yeah, this is the process it will convert. Now, what is the process it will do after that? See, it will configure the IO base and IO limit, and also it will configure the non-fetchable base limit, which is a non-fetchable memory base limit, base and limit it will need to configure, and fetchable memory base and limit also it need to configure. For the device which is the EP, it need to configure the bar address range. Before issuing any traffic, you have to be configure the bar address because it will indicate the what is the starting address for the memory request. Okay, based on that it will map the system memory. This address is mapped to the system memory. We have to configure the bar address. Okay, after that you have to configure this register, which is the IO space enable bit, memory space enable bit, bus master enable bit. This memory space enable bit means this whenever if you enable this bit means our device, which is our endpoints, will issue the completions. It can be generate the completions. Okay, for the memory traffic, it will issue the completions. If not configured, this memory space is enable bit is not configured, means our endpoints will issue the unsupported request. Bus master enable bit you have to be set. Why bus master enable bit you have to set means whenever if you set the bus master enable bit at that time our device will issue the request, which is the memory request it will issue. This is system error enable. Why you have to be enable this one means whenever, let's consider our endpoint receive one request which is malformed request it received, but it need to give response to the root port. How it will give a response to the root port? It will send the error message because that request is malformed. That's why our endpoint will send the error message. How it will send? You have to enable the system error enable bit. After configuring all the devices, then our processor will send the config package to it will issue the instruction to the host2 bridge. Host2 bridge will insert the config transactions. Yeah, this is enumeration process. If you like the content, please share and subscribe.